Okay, extending out our family of functions, looking at the different styles we've gone over so far. First off, we're looking at our linear function. So if you notice, this linear function is in the form of y equals mx plus b. So we have simple multiplication, division, addition, subtraction. Once again, that multiplicative inverse, additive inverse on here. Our parent function was our f of x equals x, or y equals x. B is our y-intercept. We have our slope. Do realize this was our linear line as we continued on. We also looked at our quadratic functions. So our quadratic functions had our curve here. Let's see if I can square this up a little bit for you. Had the form y equals ax squared plus bx plus c. They had an axis of symmetry. We had a vertex. We saw some sort of reflection on here. And we had just this overall curve. Once again, we saw an x squared in order for it to be quadratic. So under linear, there was no x squared. It was just an x to the 1 exponent. Here we've seen that we have an x squared. Absolute value functions. Once again, that absolute value function formed kind of that V, either upward or downward, once again, depending upon how it was shifted left and right. From our vertex and axis of symmetry, saw that reflection. We basically had a linear line and then a reflection of a linear line based off of that vertex point. Do realize that x was located inside the absolute value function. So it doesn't matter if we said absolute value of 2, it's absolute value of x. Okay, that absolute value of x is what really matters in here to distinguish it to be an absolute value function. Exponential functions. Once again, we had our growth model. We also had our decay model, where if we curve downward on here, remembering that 0 was kind of our magic line we had at this given point, that we kind of came down to that x-axis, either blowing away from it or gliding towards it. Once again, the growth or decay model. But our a and b were numbers in here. B was a growth or decay factors in here. So growth factor when it's greater than 1, decay factor when it's from 0 to 1. Once again, we can't equal 1 and we can't equal 0, nor be negative. A tells us a y-intercept. Also, x now is our variable, it's our input, but x is located up in the exponent. So x is in the exponent, thus exponential function. We had our square root function. Sorry about that, my hand slipped on me. Our square root function right here had our square root of x inside here, and then minus b, where it was our horizontal shift, and then we had our vertical shift within here. Do realize that with everything that's going on with this, that we had kind of this curve overall, but x was located under the square root. And then now we've discussed the rational functions, okay? So rational functions rely on that x being in that denominator. So when the x is in the denominator, that's when we had this undefined lines, okay? So what we see here is we see that we get this big table of 6 overall different functions. We have linear, quadratic, absolute value, exponential, square root, rational. They're all different functions. They have different curves, different graphs, different equations. The main key concept about this is we should be able to look at an equation and be able to go, oh, that's the type of function that we have. So let's look at some of those examples. My paper magically set up here, we can start looking at some of our examples and just kind of randomly grabbing some equations for you. So if I said that y equals 1/2 x plus 2, okay, this would be a linear function. Okay, once again, x has a single exponent, it's a product in here. If I said y equals the absolute value of 2 times 6 to the x power. Now we would be looking at this and we'd say this is exponential. Okay, once again, because x is in the exponent, it doesn't matter we have the absolute value of a number. This is just the number 2. It's 2 times 6 to the x power. Our x is up here. If I said y equals the square root of x plus 4 minus 3. Okay, here is our square root function. Once again, x is under that square root as we're looking at this problem. If I said y equals, let's go x squared over 4 plus 2, okay? Once again, because we have this x squared, this is a quadratic, okay? Even though it's over 4, this is really just saying 1/4 x squared. So we have 1/4 times this. That x squared is our key factor within here. If I said we have y equals 2 minus the absolute value of x, okay? Now we have our absolute value function, okay? So absolute value function, okay? Because once again, the absolute value is around the x. And then if I said y equals 2 over x plus 5 minus 3, okay? This is our rational, okay? So once again, we always have to try to figure out where the x is. It doesn't matter if sometimes, like the absolute value appeared in here, I could have came back here and said, well, this is the square root of 2 up here. It's still going to be a rational function because we have to look at what's happening to that x variable. What's happening to this x variable? Where's the x at? What's happening to it? That's going to deem the type of function that we have.